Hello everyone, welcome to Electric Vehicle Laboratory, Nitte Meenakshi Institute of Technology, Nitte deemed to be University. Today I am going to explain about the performance characteristics of different motors used in electric vehicles. Before going into the explanation, first we need to check what type of motors we are having, what type of controllers, and what all the equipments we are having in the total entire setup. This is our entire motor setup. Auto transformer or dimmer, power converter circuit, motor controller unit, tachometer, induction motor which is having the rating of 375 watts, half HP, 415 volt, maximum RPM is 1500 RPM, current is 1 ampere. Here we are having the BLDC motor, brushless DC motor, 220 volts, maximum RPM is 2000 RPM, maximum current is 3 ampere, and wattage is 750 watts. Here we are having PMSM motor, 1 HP, maximum RPM is 2000 RPM, and maximum current is 4 ampere. Okay. First we'll start with BLDC motor. Okay. Once again I'm going to tell this. BLDC motor is having maximum RPM 2000 RPM, current 3 ampere, voltage 220 volt, and power rating is 750 watt, 1 HP. So we are having the BLDC motor and loading arrangements. Okay. As well as here output of this BLDC motor RYB is connected to the inverter bridge inverter output RYB, and Hall sensor and back EMF sensor is connected to the converter, and the sensor input is from the motor controller sensor, BLDC sensor output, and PWM signal for the converter is given from the motor controller BLDC signals. Here we can see this is the sensor signal, this is for the BLDC PWM signal to control the motor. Now how this sensor and PWM signal is going to work for this BLDC motor. Okay, this process we are going to call it as a commutation process. Okay, the commutation process is the process where the electronically switching the current between the stator windings in sync with the rotor positions. Okay, that is nothing but depend upon the Hall sensor and back EMF. Okay, it will switch the current between the stator windings to keep the rotor in the rotation mode. Here the auto transformer, first we are going to set it in the 0 position, giving the input to the power converter. Then here we are using 2-pole 10 ampere MCB, then upper bridge connection, lower bridge connection, then the bridge output ROIB connection, sensor connection from the BLDC motor, and this is the sensor inputs from the controller, and these are the PWM signal, BLDC signal, BLDC PWM signal from the controller. This is the digital voltmeter 0 to 600 volts. This is the digital ammeter 0 to 10 ampere. Okay. Now we'll start this. First we are going to turn on the MCB. Okay. Then we need to turn on the auxiliary supply. After turning on, the blue LED light will show. After that we need to turn on this mains. Okay. Then on this controller unit. Fine. Now we can see here all PMDC, IM means induction motor and BLDC motor all are in lower mode. Okay, and this is a POT, that is nothing but the potentiometer. First we are going to set, now we are going to do the experiment on the BLDC motor, so that I am going to turn on this BLDC. Okay, now already you can see BLDC sensor, BLDC signals. Similarly, for other motors, for PMDC we are going to use this signals, for induction we are going to use this signals. Okay, now first auto transformer in 0th position. Now, as already mentioned, this BLDC motor is maximum voltage is 220 volt. Okay, first we need to set 220 volt with the help of auto transformer, maximum 220 volt. We don't want to cross that limit. Okay, first I am going to set 220 volt. We can check the digital voltmeter there. Okay, I have set it. The input voltage is 220 volt from auto transformer. Now you can see this free to rotate. Okay, first initially we are not applying any load. Okay, now as I said, POT, potentiometer, to vary the speed. Okay, now we kept this one also in the minimum position. Now I am going to vary this one. Okay, I am going to vary the potentiometer or POT. And with the help of this digital tachometer, we need to check the RPM. Okay, still it's not reached 2000 rated speed, so that I am going to increase this. Okay, now it's up to the rated speed, fine, 2000. So I'm going to load this. First note down this value, 211.8 volt, and maximum rated speed, no load, it's taking 0.55. Okay, now I'm going to load this. You can see the variation after loading, the current is increasing, as well as there is a slight variation in the voltage. Okay, so we need to set some kgs of weight. Okay, we need to note down the current. Okay. After taking the reading for 2 to 3 readings after loading, okay, for different 3 readings we are going to note down the speed, current and voltage. Okay, then bring the potentiometer POT to 0, then turn off the BLDC signal, turn off the mains, okay, then turn off the auxiliary supply, then MCB, okay, then finally we need to make this auto transformer or dimmer to the 0th position. Okay, now after making auto transformer to the 0 position, okay, you need to see the voltage in the digital voltmeter. It has to reach to the 0. Okay, then you need to turn off the mains. This is what about the BLDC motor. Okay, here you can see PMDC is having only 1, 2, 3, 4, 5 inputs, but for induction and BLDC we are having 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is having 5, this is having 7, this is having 7, and here PWM signal, here it's having 7. So that I am not going to use this 7 and 7, but I will use this 7 and 5. Fine. First I am going to connect this. Okay. And PMDC. This. Fine. Now turn on the MCB, auxiliary supply, and motor controller on, mains on. Then induction motor switch toggle switch is off, BLDC toggle switch is off, POT in minimum position, PMDC I am going to turn it on. Okay, then coming to this potentiometer, I am going to set this one to 180. For BLDC is 220 volt, for this rated voltage is 180 volt. Okay, before that first I need to check it has to be in a no load condition. Okay, now whenever I am going to turn or increase the auto transformer to 180 volt, we can see how it will run. Now I am going to keep it as 127 or 180 voltage. You can see the digital voltmeter, fine, and it's taking a 0.19 ampere, fine. Now after that, what I am going to do, I am going to vary the potentiometer. Okay, here you can see this potentiometer, and see whenever I am varying the potentiometer, and you can see this the rated speed. Fine, 1500 RPM is the rated speed. Fine. So I am going to vary this potentiometer. You can see the direction change. I am varying the potentiometer. Up to the certain limit, it will slow down the RPM, slow down the speed, then it will change the direction. Okay, here potentiometer is connected through the controller. Okay, what controller will do? Controller will change the polarity. Okay, through H bridge, it will change the polarity so that again it will increase. Okay, now again I need to see the RPM. I need to set this one to 1500 rated speed. similarly, how we did for BLDC, I am going to load this. See the ampere current. I am going to load. Okay, and I am going to note down the current, voltage as well as speed. Okay, whenever I am going to load this one, automatically the speed will decrease and current will increase there. Okay, I am going to note down the RPM, speed, current and voltage. Similarly, I am going to do it for different loading. Here we are taking 3 readings. Okay, now we have seen BLDC and PMDC. Now we are going to see the induction motor, how it is going to perform. Okay, first we need to remove the connection of PMDC. Okay, so I am going to connect my induction motor RYB. First R connection, Y, motor 3 ROV terminals to the inverter bridge ROV terminals. Okay, I have connected ROV terminals and I am going to remove this PMDC. Okay, as I mentioned, PMDC having the 5 but induction having 7, so I am going to use 7 to 7. Fine. Properly we need to check. Okay, it doesn't have to be any loose connections. We need to see for tight connection, no loose connection has to be made. Okay, this is done, connection is done. Okay, it's in the 0th position. Now here is the catch. For induction motor we are going to keep the POT at the maximum position. Okay, potentiometer at the maximum position. Fine. Now, okay, and we need to ensure free to run this no load. Okay, now we are going to increase the auto transformer up to 210 voltage. Okay, now I am going to increase this. Need to see at what voltage it will run. Now I need to turn on this MCB first. Wait. MCB auxiliary supply. Okay, then controller on, then induction means on induction. Okay, now I need to turn on this. You can see induction motor is running. I need to set the voltage to 10. Okay, now it's 211. Fine, now I am going to set the voltage at 210. Okay, you can see the rated voltage, rated speed as 1500 RPM, 1490, 1488, 1500 rated speed. Okay, now we need to load the induction motor. Okay, for the practical purpose, here we have given the loading 0.5 kg, 1 kg or 1.5 kg. Okay, here for the explanation I am showing, I am loading this, I am noting the current reading, then noting the speed. Now it decreases 1428, 1427. So similarly we can do for different loading conditions. As I said, here in the laboratory what we are doing is we are loading for 3 loadings only. Okay, then after that load this. Okay, take the potentiometer to 0th position. Okay, make this one to 0.
3.
Now we have seen the performance characteristics of different motors. First we have seen BLDC, then PMDC, then induction motor. Okay. Now what we did for all the 3 motors. Okay. For BLDC we have kept 180 volt. Okay. Then for BLDC we have kept 220 volt. PMDC 180 volt. Okay. For induction motor we have kept 210 volt. Then depend upon that, first for BLDC and PMDC, potentiometer POT is in the minimum position, but for the induction motor it's in the maximum position. And for BLDC we have connected sensors, Hall sensor and back EMF sensor, and the PWM signals from the controller. Similarly, controller will be given to all the 3 motors to the converter circuit. Okay, depend upon that we have measured current, speed for different loading conditions. Then in the tabular column, okay, what we noted is voltage, current. Okay, if torque constant is given, then we are going to calculate the torque. Okay, torque constant for induction motor, BLDC motor and PMDC motor, or different torque constant will be given. Depend upon that, the students will be calculating the torque, then current, okay, speed and torque. We are having and voltage. We are having 4 major parameters. Okay, depend upon that, how we are going to calculate the performance, how we are going to see the performance is like we are going to plot the curves. That is torque current characteristics. Okay, then the speed torque relationships. Okay, then finally we are going to map the efficiency. Okay, efficiency mapping of all 3 different motors. Then voltage, speed characteristics. Okay, depend upon the characteristics of these motors, we are going to see which one is more efficient. Okay, now
Please.
now the final conclusion is, now we are having the setup including 3 motors: BLDC, PMSM or PMDC and induction motor. Okay, now in a simple way we have loaded the motors, we have noted down the current and noted down the RPM. Okay, and with the given torque constant we have calculated the torque as well. Okay, so overall efficiency mapping, okay, has been done for these motors. Similarly, this can be extended to other motors as well for the drawing the characteristics or efficiency matching, which one is better efficient. Okay, like that we can extend this small setup to larger setup.